Okay, I think we'll get started. Welcome, thank you for coming to this session. Building great user experiences for ArcGIS Runtime apps. My name's Will Crick, I work on the Runtime team. I'm accompanied by
Nick Black, I work on the apps team.
Thank you very much. Both got British accents, don't know why that is, very bizarre. So before we get started, let me ask you guys a few questions. Who is currently building an application with Runtime? Hopefully most people. Who is planning on building an application with Runtime and just trying to get background information? Okay. Who would consider themselves a user experience guru? There's one that definitely should be over there because he works on our team. Okay. Okay, good. Who's somebody who wants to be a user experience guru? Everybody need to put their hand up, otherwise get out. Okay, good. Thank you very much. Just good to get an idea of who I'm talking to so I can tailor it a little bit. So, content of what we're going to do today. Can't really see that. Can you guys see that slide okay? Seems to be, I can't see it particularly. Yeah. Let me see if we can find something to dim the lights before we get started. That was good. Oh, is that better? Yeah. Okay, there we go. There we go, good, because I need to read the slides, because otherwise I won't know what I'm going to say. So what we're going to cover today is kind of where do we start, how do you get started, what do you need to think about when you're building user experiences. Nick's going to talk about what makes a good user experience. And we're going to look at some patterns associated specifically with mapping applications and location, and talk you through some of those patterns that we've come up with that we think are just useful for you guys to understand. And then we're going to spend most of the time on applied patterns, just showing you demos of applications that we've built and just talking about some of the user experience choices that we've taken in building those applications, because we think that's probably the best way of actually demonstrating some of these concepts rather than just purely through slides. So first of all, what are runtime apps? Hopefully you all kind of know what that is already. But obviously we have out-of-the-box apps built by Esri on top of the runtime, such as Explorer, Collector, and Navigator. And obviously the cool thing for you guys as developers is you can put your app here and make loads of money. So hopefully you're not all just purely motivated by money, but sometimes it helps to get paid. So kind of where do you start when you're thinking about building an app? The most important thing is to get to know your users and work out whether this delightful app that I designed, see, this is me as a user experience designer, whether this is what your users want. Everybody just wants ArcMap on a phone, right? That will work. So before you can make the decisions about whether that is the app that you're going to build, you need to understand what your users are, what their goals are, so that you can streamline the tools and the user experience that you build into that app to allow them to be successful. So get to know them, try and understand what platforms and devices and form factors make sense for your users, whether you're going to target phones or tablets or desktops or all of them or just one of them, because that really affects how you're going to design your application as well as understanding the form factor. And also think about where people are going to be using it. Are they going to be using it in the office where there's a fully connected Wi-Fi, or they're going to be out in the field where there's offline scenarios? Are they going to be using it outdoors in bright sunlight where you might want to think about the different colors and the sizing of the tools? Are they going to be wearing thick gloves, or are they, army clad in different kind of clothing that's going to make it difficult to use your application to size your buttons accordingly? But the more research you can do about the user, the better it is and the better user experience you'll end up designing. And then once you kind of understand your users, you should start to understand the platforms that you're delivering on. Try and understand the capabilities and the user experience patterns that you're working towards. So understand the Android patterns or the iOS patterns or the Windows patterns to make sure that the user experience that you're building fits in with those patterns and feels natural. So that's kind of where you start out. I'm going to hand over to Nick to talk about what makes a great user experience.
Sure, thanks, Will. So what do we even mean when we talk about a great user experience? I think to some extent, everyone has their own kind of unique perception of what a great user experience is. But if you look at some of the most successful apps out there, some of the best apps, they share some common underlying traits. And I'd like to talk to you about a couple of them now. First one I'd like to talk about is the value. So the value that's provided by your app. What does it do? Who is it for? how is it going to be useful to them? And this boils down to solving a real-world problem. This could be creating something new or improving an existing experience. For example, Uber's a great example of spotting a couple of real pain points that you used to have when you used to call a cab. You might call to order one, but you don't know where it is, you don't know how far away it is, you don't know who's driving it. You've got to spend time at the end to actually pay with a credit card or cash. I mean, what a hassle, eh? And if you leave something in the cab, you can't easily contact the driver to get it back. And Uber solves a lot of these problems on multiple levels, and it's pretty cool. The second thing I want to talk about is usability. So your app might contain the best, amazing functionality and amazing technology, but if it's complicated and can't be used by your target audience, then that value can't truly be realized. And it's a designer's job to try and make things as easy to use as possible. Simpler apps are easier to explain, easier to build, and easier to change if you need to pivot. That said, it can be sometimes really difficult to keep things simple because there's a lot of problems out there, and each problem can be inherently pretty complex. So to keep things simple, it really helps to hone in and focus on a single problem. And one effective methodology that we use within Esri is the Google Ventures Design Sprint. How many people have heard of the Google Ventures Design Sprint? 2 people at the back. Oh, and one's Andy, one of our designers. Brilliant. So a design sprint is a week-long group activity for narrowing in on a problem through design, prototyping, and testing ideas with customers. It has some really good advice on both how to conduct research before the sprint and how to synthesize that research collectively during the first couple of days of the sprint. And this really helps you prioritize what problem you want to focus on. And if you get that right, the rest typically falls into place pretty easily. The final thing I want to talk about, and this is something I added to the slide this year that's not often talked about really, and it might seem pretty obvious, but ensuring your app works properly is key to a great UX. So this includes trying to track down and fix as many bugs as possible, either in the code or issues with the data that you're displaying. But to me, quality also covers the attention to detail and crafting the UI, sizing and positioning elements on the screen, choosing the colors, font sizes, font weight, making sure your animations are smooth and your transitions are smooth. These things aren't necessarily things that users will consciously notice about your app, but they all contribute towards how a user feels when they're using your app. And we'll see some real examples later of how tweaks that improve the quality can really turn something good become really great. So solving a real-world problem, ease of use, and quality, those are 3 key aspects of a great user experience. So why am I telling you all this? Why do you even care about creating a great user experience? Well, I'm assuming you care because you all came to this session. But aside from that, a good UX can really give you a competitive advantage over other apps. From a consumer app perspective, this is as crucial as ever, because in 2016, 23%, almost 1 in 4 apps were abandoned after their first use. Some of you who work in the enterprise might come from a different perspective and say, well, my guys are forced to use this app. They can't delete the app off their phone, so what does it even matter? Well, that's a little bit short-sighted because at the end of the day, you're creating this app to create value and help them be more efficient with their job. And if you give them a great user experience, they're more likely to use your app. They're more likely to be happier that they're using the app and be more efficient in their workplace and generally happier and more productive. So these are 3 things that you might want to consider when you're creating a new product or a new feature in your app. There's always a balance between desirability, feasibility, and viability. So desirability is, do people even want this thing? And it comes back again to the value that you're providing. Feasibility, even if people do want it, can you actually do what you want to do? Is it even possible to do what you want to do? And thirdly, viability, is it cost effective to do it? For startups, this could be, are you going to make a business out of it? Or if you're in a larger organization, is it worth the investment? the time and the resources that you're going to put into this thing. And typically the most valuable design lies at the intersection of these three things. One of the most exciting and one of the most challenging things about working in technology is that things evolve rapidly, and what's possible is changing all the time. You can see this with the evolution of the Runtime SDK, so bringing in vector-based maps and packaging maps to be used in offline environments. And whilst products should be user-driven, it's always important to have an understanding of the underlying technology, since as a designer, these are the constraints in which you're working. Today, we're going to be looking at some common ways applications in the real world are using maps and your location. So developers in the room are probably aware what design patterns are in code as a generally repeatable solution to a commonly occurring problem. This is not a finished design that you can transform directly into code. It's more of a description or template for how to solve a problem that can be used in many different situations. In a similar way, design patterns can be applied to your app if you need to incorporate a map or location, or use your device's location in your app. We're going to outline some patterns that we've learned by building location-based apps and observe how maps have been integrated into other apps in the wider App Store ecosystem. These patterns should help you leverage the ArcGIS Runtime within your own applications, and I'm going to hand over to Will to talk about the first one, which is the Map-Centric App.
So the Map-Centric App is what us as mapping developers typically always think about first when we think about embedding location in an application. We put the map as the first screen that you see. It's the most important thing, and anything beyond that is kind of subsequent information. And that's fine, and there are some applications that warrant that pattern, but it's not the only pattern, and you'll see the other patterns later on are just as important. And actually, the more you understand about how your map is used in the context of your application allows you to build a much nicer experience about how you position that map and what kind of tools you add onto the map, how you worry and think about cartography and gestures, how you think about where that map lives in the hierarchy of your other views. So some examples of map-centric apps are Collector. This is the new user experience for Collector that I don't know a huge amount about because Nick just stuffed these slides in there, but it looks lovely. But essentially, it's a very map-centric application, Collector. It's all about getting to the map that you want to open and then adding features and editing features in that map. And users would expect to get to the map as soon as they possibly can. So because the map is where that user is going to be really productive, you want to make it so that the user can get to that map really quickly. Also, you might want to think about having patterns where once they've got to the map and they've quit the app, when they reopen the app, does it go straight back to that map to allow them to keep working really efficiently, or do they have to drill through the views to open up that map again? In map-centric applications, it's typically good to get to the map as soon as possible. If they've previously opened a map and they viewed a specific extent, then open that map at that same extent, and without them having to go through that whole process of getting there again. So there are patterns like that with map-centric applications that you should want to think about when you're building your user experience and persisting the map state between application settings. This is another example of Collector, the new version of Collector on Windows. Again, map-centric application, but it's on a tablet. So instead of providing a full screen map view, it's actually put some other information in a side panel, and that's fine on a tablet. So you can see how, depending on the form factor of your device, the pattern for when you're working with your maps and the things that you think about how you obscure your maps with other content might change. The more real estate you have, the more flexibility you've got in terms of overlaying other content on top of the map. And I think this is showing, so this is showing the picker for adding new features on the left-hand side. The other thing, I suppose, to add on to map-centric applications that I've thought about is, do you want to provide a legend? Obviously, we always provide a legend, right? But ideally, with map-centric apps, you should be able to think about the cartography in your map such that the user doesn't really need a legend. The legend's there for a last resort. Ideally, the symbology and the cartography that you've added for your features in the map should represent what that map is, and they shouldn't have to always look at a legend to find what things are. When it comes to specialized symbology, where you're working with either military symbology or utility symbology models, you might have to have those legends. because they're complex symbols that you need to expose, but otherwise just try and think about symbology and cartography or map as part of the user experience of your application. It'll serve you well. Another example of a map-centric app is ArcGIS Earth. Opens up with the globe straight away, right in your face, and there's really no other views associated with that map. The app is the map in that context. And it's all about adding the right tools and the right gestures so that people can interact with that map, because that's literally all they're using that application for. So that's the most common pattern that we think about, but I suppose actually we end up building map-centric apps a lot when we probably shouldn't. So please focus on the other things, the other patterns coming. I'll hand over to Nick for the next one.
Yeah, so I'm going to talk about maps for context. So 74% of adult smartphone owners say that they use their phone to get directions or other information based on their current location. In fact, if your app content has any kind of spatial characteristic, users may expect to get to a map view of that content to see where it is, and more importantly, to see where it is in relation to their current location. When a map is used for context, the map is not the main focus. The app could still function perfectly well without the map, but the map is there for added value, for the additional context to the presented content. So I'm going to flip over to do a quick demo here, and that didn't work. I'm on 4. So here I am in Airbnb, where you can see a list of available properties in San Diego. You can see at the bottom there's a map button that at any point I can tap on that to toggle to a map view of the same content. This provides me an alternative view which allows me to focus in on different geographical areas of the city. And this can help me make a decision on where to stay. Notice there are no map tools, and users can query the map to reveal properties at that location. I can also drill in and get more details about a particular property directly from the map. Here the map is presented modally and can easily be dismissed to return back to the list by hitting the X in the top left. So that's using a map for context. Pretty simple, right? The nice thing about this pattern is that although the map isn't the primary view of the app, when it does come into play, it's afforded enough real estate to be useful, and the users can easily interact with it. So now I'm going to talk a little bit about location alerts. So devices allow us to know where we are and what's around us. And it opens up some really interesting possibilities for alerting users with relevant content from our apps. And alerts are provided using background services and system notifications. And in order to get these to work, you're going to need to ask the user's permission to do 2 things. Firstly, permission to obtain their location, and secondly, permission to notify them. Asking for these permissions will launch system alerts that prompt the user whether they want to accept. So make sure you set the context before launching these alerts so that the user isn't surprised or bombarded when they first open your app. And we'll see in a demo later on how an effective way you can do that in one of the demos. So if you prepare your users and let them know why you need these permissions, it will make them way more likely to accept. Going on to kind of location alert strategies, there are various different strategies you can employ for obtaining the location and alerting the user. Standard location updates allow you to register with the location manager on the device, and this will call back to your app's code when the user's location changes. Crucially, the app must be running in order to receive the location updates using this strategy. You can specify the accuracy you need, and this can actually have a dramatic effect on your battery life. In iOS, for example, if you specify an accuracy of anything above 1 kilometer, the operating system will actually stop using the GPS chip and start using cell tower and Wi-Fi to obtain the location. Anything below that, and your GPS will be kept on the entire time your app is running, and it will burn a lot of battery. It's also worth checking the accuracy of the returned location, the location that's been returned from the location manager, to see if it's going to be good enough for what you want to use it for. If not, it could result in bogus notifications to the user. There are also APIs to test to see if the device is plugged in or not, and this can be useful because you might want to vary your strategy according to these variables. If you want your user to be notified when your app is not running, check out the region monitoring and geofencing APIs. These APIs detect whether the user has entered a specified circular region, and they tend to be more efficient in terms of battery life, but slightly less accurate than the standard location updates. If the location manager detects when a user goes into a region or out of a region, it will start your app up and allow you to respond to that event. Finally, final note on this is don't underestimate the value of QA to test out these strategies. Test early and test often and test with different devices. Our experience of testing out what we thought was a good strategy, often once we actually got out to the field, it meant that we kind of realized it was probably the wrong strategy and we had to rethink things. So definitely worthwhile QAing things before you release. So I'm going to hand it back over to Will now to talk about location search.
So the pattern that Nick just talked about was an interesting pattern because it included location in your application without any map. Okay, just purely how you use location information. And actually this next pattern is very similar to that in that you're using the location to search and filter your results, and you're maybe embedding some location information in the list, but you're not always showing a map. So this happens to be an application that I use from time to time. Untapped allows me to check in beers that I drink. And you can see that I can look for nearby beers, okay? And these are all the check-ins that are near me. And it's sorted them, I think these are actually sorted by time, but because there's a geographic component, you could decide to sort them by distance. So you're using location and presenting some location information to your users, but without embedding a map into it. I can also look for a list view of nearby venues, and in this case, it is sorting it by distance. So you can see there's 1.9 miles away for a few of them and 2 miles away. So that's the nearest bars to my house. That 0.1 mile makes a big difference, I assure you. So the thing about this one is it's very common to provide a list and use the location for search, but you can also combine this with the other pattern of showing a map for context. If you want to show these results on a map, you can, but the map's not the most important thing here. The most important thing to me is what is the closest venue that I can get to the quickest. I don't really care where it is, as long as I can get a route to it later. I don't really need to look at it on a map. You get the next slide for us. Yeah. I'll stand over this side there now. So the pattern for how you use location as search is typically this. You get some kind of location, you either retrieve it from the device location manager or it's a geocoded location. And that's the kind of orange dot in the middle there. And then you use a search catchment to decide what features near that location are you going to find and present to your users. And this means that, geographic searches have to have some kind of bounding, okay? You can't just ask for the nearest 100 features because actually the algorithm for that is quite difficult. We haven't solved that in ArcGIS. So typically you get asked for a particular radius and you find results in there. If there's enough, you're done. If there's not enough, you can ask for a larger radius. But typically what happens is you kind of end up clipping out some features that are quite close, but you end up with a nice set of features that are inside your catchment. And then you can start to show the results of those in your list, and you can start to embed and enrich those results with spatial information. So I've got an application here that I'm going to demo that's actually quite a good example of this that we built for a hackathon called Drift. Well, thank you very much, Nick. Set up for me by my assistant. So this application allows you to get directions. The actual fact that it incorporates directions is pretty insignificant in this case. The most important part of this app is it allows me, if I'm driving from my home to Carlsbad, it allows me to find things along the way that are of interest to me. And we've called this drifting. So I can drift along my route and I can search for food. And I can say, when do I want to stop? And this, I know the route's going to take me 91 minutes, but I want to stop halfway. Let's say I want to stop around 40 minutes, in 40 minutes time. and I want to find food that's a minimum rating of 3 stars, maximum cost of $3, but I only want it to be 1 mile off my route or route. Let's switch between 2 of those. So now I can find those. And this is basically using exactly the algorithm I was talking about. It's searched along my route, it's picked some boundaries, it's used the Yelp API to go and search for some places within a specific distance off the route. And it's sorted it by, I think it's sorted it by a combination of ratings and distance. So using those 2 features, some geographic information and some information from Yelp to give me the best location. And if we actually go and have a look at where these things are on a map, this again is not that important to me, but what I wanted to do is I wanted to show you the secret sauce associated with this application. So this is the algorithm that it's used. It's very similar to what I just talked about. We've defined a catchment, but instead of defining one, we worked out where we would be in 40 minutes time and then used the route to generate a number of catchments, and we used those little circles there to send requests to the Yelp API. And then when the results came back, we did some post-processing, because Yelp doesn't always send you stuff within the region that you're interested in. So all of the yellow dots have been filtered out, and all of the orange dots are what's included in my list. And then we've decided to sort that ourselves. So this is just an example of one of those algorithms of using location for search. And really for me, the most important thing is this list here. The map, not so important. This is the information that I want to get to, so I can go and decide to drift to Tavern Grill, and that's added that location to my route, and it will just direct me there with my directions as I go along. So that's just an example of an application we built. The source code of this application is actually on GitHub, because we built it as part of an internal hackathon. There's a link to it on the slide. What number is slide 5? 16. Link to it on the slide, so you can go and get it and have a look at it if you want to. So I think that's it. That was location as search pattern with an example.
Sweet. Yeah, I'm going to talk about a few more applied patterns. You could kind of say that was already an applied pattern. But before I actually get into that, I want to talk about a couple of people that I work with in Portland, Maine. And the first guy, and you might notice him, he's actually in the room, is Justin. And this is his avatar. I don't know if it relates to what he actually looks like. But he's a great designer. He works with us on the apps team. When he's not thinking of great design ideas, there's a pretty good chance he'll be thinking about craft beer. So I went to Boston with Justin, and we went to a conference together, and we were on the lookout for a particular beer from a particular brewery called Trillium. And we had a look on the Trillium website, and we found a restaurant, and they said they had the beer on tap. So we went there, got a table, sat down, and when we sat down and ordered drinks, turns out they didn't actually have the beer on tap. So we were pretty disappointed. And the next day, obviously, we called ahead just to make sure that they definitely would have the beer on tap in the next place we went. So the next person I want to talk about is another guy that I work with on the apps team. He's actually the CTO of the apps group and also a great iOS developer, also in the room if you can recognize him by his avatar. You could consider him more of a complex individual, because when he's not thinking about Swift code, most likely thinking about either the Patriots or Bissell Brothers beer. And Bissell Brothers beer is actually an amazing little brewery local to Portland, Maine. Some brilliant beer. I'd definitely recommend checking it out if you're ever in the area. But Jeff had a similar problem to what Justin and I experienced when we were down in Boston. And that one day, Bissell Brothers had released a new oatmeal stout called Umbra, and that he hadn't tasted yet. And he couldn't find it on tap anywhere. He went from bar to bar to bar, and he couldn't find it anywhere. So we thought, hang on a second, there's a common theme occurring here. Like, we want to find out where this beer is. How can we do that? So when we were down in Boston, Justin had mentioned to me that we might be able to use the Untapped APIs in order to find out where the beer is. So Will had mentioned this Untapped app earlier in this presentation that allows people to check in beers and rate them. And part of checking in is actually adding a location to where these beers are. And Untapped are pretty nice because they provide APIs, so you can find out who is checking in beers and, crucially, where they're checking them in. So this was really appealing to us, since if we could harvest this crowdsourced information without the bars and restaurants having to do anything, it seemed pretty viable. So manually calling the APIs, we actually plotted the results on a map, and true enough, we could find out where people were recently checking in these beers and the location of them. So now I'm going to, okay, one more slide. So going back to the desirability, feasibility, viability, yes, we want to know where the beer is. Yes, it seems like we can find out where the beer is. And finally, well, we can do design and code. That's what we do every day. So we thought, well, yeah, it seems pretty viable. Are we going to make a business out of it? Probably not. But our hope was that we might get some free beer. We're still on the lookout for that free beer. So you can get this app. It's actually on the App Store right now, but it's probably not worthwhile since they don't ship outside of Maine unless you are from Maine. But now I can show you, I'm going to show you a kind of before and after. So I've got a build on my phone that you can see now. And this is a build of the BB on Tap app from back in December. And it's pretty far along. So this is the initial screen that you see when you fire up the app. And this is what I was talking about with the location alerts. We actually present initially a screen that allows the user to understand that this app needs your location. It tells you why it needs your location, and there's a big button that if you press it, will show the system prompt. If you allow the app to use your location, the app's going to spend a little bit of time to start up, and a bit longer. So when you start up the map, I can see a list of the various venues that have reported Bissell Brothers beer. I can tap, well, the map doesn't seem to be loading, and it's going very slow. Let me just turn Wi-Fi off.
It's not a map-centric app, luckily.
Yeah, so there we go, that's better. So now I've got a map, but crucially I've got the list of various venues that reported Bissell Brothers beer. I can tap on one of these venues to see where it is, how far I am away from it. You can see I'm pretty far away from Thistle Pig, 2,500 miles. What beer was reported, how long ago it was checked in, so you can see the substance, that's their IPA, flagship IPA, that's pretty tasty. And I've got additional options to get directions or call. And you can see we're using a component here that was highlighted in the plenary called the sliding panel. And going back to one of Will's points that mentioned earlier about kind of conforming to operating system kind of conventions, the sliding panel is actually something you'll see in a lot of Apple's new apps. So things like music, things like the new Maps app, they're using this sliding panel. But unfortunately for us, they don't actually provide this component in their SDK. So we had to build our own sliding panel. Maybe in future they may release it, but we don't know yet. But including a panel like this, it kind of makes the app feel natural to the platform. And we spent a bunch of time trying to get the experience of this panel to feel right, with smooth animations and positioning. So a couple of things you might have already noticed about the app. Well, firstly, the startup seemed pretty slow, right? It was about 10 seconds. And when I asked Jeff, the developer, like, why this was, he gave me a breakdown of why it was. And the request for the user's location took 10 seconds. All of the other things like retrieving the venues, retrieving the schedule, loading the map, were all about a second. So we have that activity up there for 10 seconds, and it kind of makes the app feel like it's really slow to start up. And the initial extent is also a little bit weird. I mean, I can't actually see my current location unless I kind of move this panel down. And actually, the amount of map that's showing, it's kind of small and it's not necessarily easy to interact with. One of the other things worth noting is when I zoom out, I see a bunch of different places, a bunch of different venues. I've got a bunch, around Portland here, and we've got a load of overlapping symbols that kind of looks a little bit ugly. So we wanted to do something about this. So let me flip over to the latest version of the app, and we'll show you a couple of things we did. So the first thing you'll notice is a quicker startup. And to combat the time it took to actually retrieve the user's location, we set an arbitrary position, and when we get the location from the location manager, we move the map to your current location. So that's the initial startup thing that we fixed. The second thing is the panel's position. I can now see more of the map, which makes it kind of easier to interact with. And I can see my current location on the map. You'll actually notice that we still have a minor bug here that when the app starts up, the current location isn't centered exactly where you'd want it. We kind of want it positioned right in the center here. But that's the thing, right? Like you can't necessarily have everything. And we're constantly fixing bugs. We're constantly improving and iterating on this app. So one other cool thing I'm going to show you, we had all those overlapping symbols. So how do we solve that? Well, you can see we've got some really nice clustering happening here. So rather than showing 30 overlapping symbols, we show the venues as a cluster that I can tap on, and by tapping, it kind of zooms me in, and this allows me to really quickly and easily get down to a set of venues that I can tap on individual venues and find out more information about it. You might also notice some additional functionality if you do ever get this app in the store, and that is one of the first pieces of feedback that we got from people when they were using this app is, how do I actually find a beer or a venue? Because we didn't have a search. So, and actually, that was a little bit of an oversight on our part, because when we actually think back to Jeff's problem that he originally had about finding Umbra, we just want the ability to find whereabouts Umbra is. So I can just type in Umbra, and it will show me the venues that have that beer, and I can tap on them to get more information, just like any of the other venues. So we also refined the panel interaction slightly. So previously, and I didn't demo it before, but when you swipe near the top of this panel, rather than moving the panel down like this, it would actually pan the map. So that made it pretty clunky to try and get the panel out of the way. In the most recent update that hasn't actually been released yet, we've actually added a nice extra bit of functionality that you might appreciate. And that is a nice little Easter egg with beers falling from the sky. So maybe not so useful, but a little bit of fun that's coming soon. Let's flip back to the slides quickly. So I don't know how many of you saw the Hangar 24 app in the plenary this morning. Few hands got up. It was towards the end, so I don't blame you if you didn't see it. But this app might actually be more useful to you while you're here at the conference, because Hangar 24 is a beer local to Redlands, where the head office is of Esri. And we actually put an app in the store to allow you to find Hangar 24 beer around California. And you can actually get this app in the store right now. But what might be interesting to you from a developer perspective is that the way the app has been built, we can easily theme the app. So we can, with minimal changes, actually use exactly the same code base and tweak things like the colors, the symbols that are used, the base map, and things like that. So that's another thing to consider if you've come up with a good idea and you actually want to reuse that idea for a variety of different use cases. So I'm going to hand back to Will now. He's going to talk about ecological marine units.
Emus.
All right, emus. Okay.
So this is another app that was demonstrated at the plenary this morning, ecological emus. I suppose one of the aspects of this application that was interesting was how we prepared the data and how the different types of data layers had different performance implications that actually ended up affecting the user experience. So what I want to do is show you the app running on Android device. So what we wanted from this was this application shows the distribution of these ecological marine units across the surface of the ocean. But obviously, as you step down through the depth of the ocean, you get a different distribution. And there's a web app that came with this that had a tiled layer for the global distribution at the surface, but we thought it would be quite cool to add this little slider in the top left so that you could actually look at the different distribution of emus as it goes down through the depth of the ocean. We thought that would be quite easy to do. However, the ecological marine unit dataset is 52 million points, and for every point, there's multiple depth data. And so for us to come up with a simple way of representing that in an application was actually really difficult. In previous versions of this talk, we had some slides on how different data layer types affect the user experience, but this is actually a much more interesting way of drilling into how that works. So if you look at the very surface, if you look at the top, this is the tiled layer, and actually you can see the 52 million points that make up all the data sets. And the layer that you're looking at right now is a tiled layer. So as you zoom in and out, you get pretty good performance. As you pan and you zoom, you can't see too much, but actually when you zoom in, it starts representing itself as points, which is a bit weird because you can't really see the distribution of that unit in its entirety. So we wanted to change that a little bit, but if you think about what you'd have to do to cache the data at every single depth level, that means we'd have to build a completely new tile cache for every single one of these depths that we want to zoom to. And doing that would not only take a huge amount of time, would be quite long from a data just from a data processing time, but it would also take up a huge amount of server resources and a huge amount of disk space. So we didn't want to do that. Even though the user experience that you get at the end of it might be quite nice, the actual implementation of that wasn't very possible. So we tried out lots of different layer types. We'd have the same problem with vector tiled layers, that was an option, but we'd still have the same problem of having to build multiple caches and maintaining those. We thought about using map image layers, dynamic map service layers, and being able to do custom filters on those, but we actually found the user experience of doing that wasn't very nice, so that as you change the slider, you didn't quite get a nice update to the data. And when you panned around, it wasn't able to cache the data, so it had to go and make an additional request for it, so we didn't quite get the user experience we wanted there. So what we found we wanted to do was work with features and feature layers and actually cache them in a feature table. But obviously 52 million points isn't going to work because requesting those over the network is going to be difficult. So we wanted to work out how we could generalize those points into a really efficient data set. And actually, a guy, Mike's, written a whole blog post on this and spent a lot of time trying to work out these generalization algorithms of first converting the points to polygons, but then doing that with the minimum amount of vertices so that actually the data that we requested in the app was really fast. And you can see that as you slide through, you actually get pretty good performance with this. It's still not ideal. Ideally, we'd be able to pre-cache some of this data for you so that as you zoom in and out, the data's already there. But the nice thing about using the service feature table in runtime is once the data has been requested once, it's already there in the table and it's cached and we don't need to request it again. So once you've done it the first time, you now can get a really nice visualization of how things change over time. So there's a blog post out on this and there's documentation on this application, and the source code of this app is also on GitHub, and you can go and check it out and kind of learn how these different layer types affect the user experience in your application. And then the next one I think we're going to talk about is an indoor navigation app, also that you saw on the plenary. What's number that for? Built by Mara, who just walked in. She's sitting right here. Oh, let me just enter the really difficult password before I show you that on the screen. There's no way you'd be able to guess what that is. You got it? Okay. So the reason I want to show this application is just about gestures. Again, in previous versions of this talk, we talked about what default gestures in your application should be, and some of the decisions that you want to make in doing that. And actually, the best way of showing this is just by showing this application. So here we have the Redlands campus. You can zoom in to find out who's occupying my office, not me. Maybe I've been noticed of something. Maybe I've got the sack, not sure. But luckily this data is anonymized, so it doesn't mean anything. But what you notice there is that the default gestures of zooming are obviously baked into the SDK, and they're all there for you from the runtime point of view. That includes rotation. And one interesting thing you'll see here about rotation is if I get the rotation close to north, it actually snaps me back to north, because we know how difficult it is to get it right back to north yourself. And this is, Mara, is this default in the .NET Xamarin SDK, that snap? So it's not a default gesture in all of the SDKs right now. I know it's not on Android, I think it is on iOS and .NET, but it's something that we're trying to bake into the API from a gesture point of view, just to make it so that your applications, you don't have to write too much application logic code to make that kind of stuff happen. The other thing you'll notice is that when I tap on the map, the default gesture is to do a search. That's something users expect most of the time. That's something that we can't implement in our API by default. So you as an application developer need to override that tap gesture and implement it to make it do something. We have provided you with a really simple identify operation on the GeoView object, which allows you to search all the layers in your map, because that's typically what people expect to happen when you tap on the map, is that you do a search. So that's all very good. So let's just quickly create a route from there to M3 South Atrium, and that gives me a route. It looks like it goes, it's on the, interesting, goes from floor 1, I suppose, and up the stairs to floor 3. But because we've got the default gesture, we typically, before we had the default gesture of tap doing a query, but now when you tap on the map, it actually asks you a question whether you want to clear the route or keep the route. And this is where the default gesture has now changed in the application. Now, I'm not saying this is the best pattern, I'm just saying this is the type of thing that you need to think about. The other functionality that's required in this application is to be able to clear the route, or so that you can do a new one, because there's no other way of clearing that route from the screen. So I think Navigator, the Navigator app has this same pattern. And Apple Maps also used to have this same pattern, and Google Maps have this same pattern. But actually, when we were just before this session, when we were looking at Apple Maps, we've seen that they've now changed that pattern, so that now there's a different way of clearing your route, and tap in Apple Maps still actually doesn't identify. Because it's quite annoying when I'm going along this route, I say, okay, I'm going to go past this office. Okay, who is it who works in that office? Oh, okay, I have to clear my route, click on the office, figure out that it's Melvin Milder, great name, and then I need to go back and do my route all over again. I've now lost my route. Okay, so the gestures really have an impact on the flow and user experience of your application. So you want to think really critically about how you override them and what they are in your application. And it's very difficult now with all the different platforms, all the different design patterns, all the different applications changing, like Google Maps on iOS does one thing, Apple Maps on iOS does another, Google Maps on Android does something slightly different. If you're building a mapping application, you want to try and keep up with the patterns in those apps to make sure the apps you're building have a similar user experience, or you try and define your own. But it's very difficult to teach users how to use your application if it's the only application that works in that way, because typically people will not expect that to happen. So if you are trying to teach your users to do something new, make sure you do it very well, or avoid it and stick with the common application patterns that are found on the platform that you're working with. So that's just about gestures, and I think that's pretty much it.
Yeah.
Got a few slides on resources, on where to go to find out more information about this. Obviously, the developer's site is where you should go to find lots of guide documentation. We've actually got the patterns that we talked about today, and a few others are written up in some guide documentation in the SDKs themselves. So you can go there and find and read about those patterns and learn about the things that are important in each case. We've got lots of resources from a developer point of view. We've got API and workflow samples, but typically they don't have much user experience in them at all. They're really bare bones basic samples. They might have some really basic material design patterns on Android, for example, but there won't be much in there. Toolkit components, we currently don't really have any, although I did see Morten just tweet that the .NET Toolkit components did just get published today, so you'll be able to use some .NET ones, but they're in beta form. But these Toolkit components are user experience components that we've built into the SDKs that do common things like overview map, measure tool, scale bar, legend, table of contents, stuff like that. So they have user experience components in them, they have UI in them, but they're there for you to go and customize. We have our demos repos, which have all of the apps. If you don't see them in our samples or in their own repo, then you'll be able to find them in the demos repo. So quite a few of those will have user experience aspects to them that you can go and check out. But the most important thing that you heard in the plenary is that we're building these example applications, 2 of which I've demoed today. And these do have they're fully blown apps with real-world use cases. So the user experience aspects in them are things that you can go and have a look at and dig into. You can look at the gestures in the indoor routing navigation app. You can look at how we did the slider in the ecological marine unit app. And there's a bunch of other apps that we're working on as well. So there's loads of places you can go to find out more information and dig into the code of the applications that we've built and demoed today. And by the sounds of it, you can go and get the VB on Tap app in the store. But can you look at the code? Is the code there? Code
if you come over to the island, and you might be able to find Jeff Jackson, who could. He's actually sat over there as well.
2 pieces of code I'd be very interested in looking at is the clustering and the bottom sheet thing.
Is the routing one, does that use Xamarin Forms or does it use native iOS?
Native iOS, yeah. Good. Okay, I think that concludes our session. Thank you very much. Any questions? Yep.
Is there anything specific, like with the Qt runtime that's, I guess, lacking in comparison to running a specific iOS runtime, iOS runtime, or .NET runtime?
Okay, good question. So, question is there anything specific? What's the difference, I suppose, between the Qt controls and the capabilities you can build versus the native iOS or Android runtimes? So, Qt is an interesting cross-platform technology. It actually has built its own UI framework, essentially. So everything that it renders to the screen, it is in control of. So it doesn't render a native Android list view to the screen and reuse that. It actually has its own list view implementation. That's really cool because it means the UI that you build works across all the platforms. But what it means is that you can't hook into the native Android user experience or iOS user experience. They have mocked that up from a styling point of view, so they make their views on Android look like Android list views and grid views, and they do the same on iOS. But actually it's rendered using their own technology, not using the platform's technology. When you're working with iOS and Android APIs, you are leveraging the OS implementations of those views, which allows you to do all of those cool things that users on that platform would expect. Qt's doing a really good job of adding those components to the Qt API to try and keep it up to date, but it's obviously just lags a little bit behind. Like it's now added a material design set of widgets that allow you to do floating action buttons on Android. But something that you can't do with Qt, for example, is hook into the download manager, and the notification framework fully and integrated with that. Like that's capability that they're going to have to build themselves, and it's quite difficult to do. So there are some things like Qt is really good for cross-platform, but it doesn't allow you to really leverage those native components as much as the other APIs. Xamarin, on the other hand, with Xamarin iOS and Xamarin Android, you're actually leveraging an Android view or an iOS view controller. So with Xamarin, you can choose to actually leverage the native capabilities of the platform, but you're doing it all in C#. And it has another set of things that you can't do. But the question about kind of what cross-platform technology you use is by no means a simple answer. It's worthy of a whole session on its own. And I think there is one, actually. Can't remember when it is, but there is a cross-platform session. 4 o'clock today. There you go. Right after this. Good stuff. Thank you. Any other questions? Yeah.
Yeah, I had a question. The Toolkit Components, is that going to include any of the new sliding panel implementation, or is that more of a...
Yeah, the Toolkit Components are much more focused on GIS apps that we're building, so, classic GIS. It'll have the user interface in it for that, but whether those components will leverage things like the sliding panel, right now we've got no plans to do that, but we might do. If we find a component that needs it, then maybe we'll steal Jeff's code.
If people are interested in that, I can turn that into a repo that if there's iOS built or something
Cool. Sounds good. Like that, Jeff. Thanks. That's great. Any other questions? Yes.
Yeah, something you mentioned at the start actually piqued my interest. A common complaint that we get, because we deal with a lot of people that have to wear gloves and cumbersome equipment. Have you dealt with that before, and how do you get around it other than sort of having like 2 big buttons at the start, and you only ever have 2 big buttons and so on? So, for example,
Sounds like you've solved the problem right there.
Yeah, just that problem of you can't rely on the fact that they're going to be able to use gestures, because they may not actually be allowed to take off their gloves because it's a dangerous situation or something like that.
Right. So repeating the question for the recording is, have we got any experience solving problems for people using cumbersome equipment and gloves? Personally not. Maybe some of the designers in our room might like to comment on whether they've had to deal with anything like that.
We've used, in past experiences, wearables and different types of technologies for giving the user feedback and giving them something easy that they can interact with. But typically, it is a big challenge when you're working with people with gloves or some type of obscure gesture.
Yeah, I know that certain gloves have certain sensors in them to allow them to work with screens and gestures. So it kind of depends on the equipment that you're working with. But I don't think there's no kind of single silver bullet to solve it apart from big buttons. So, it sounds like they should work. Problem is, you can only have a certain number of big buttons, right?
Or a stylus.
Stylus, yeah, I suppose additional tools, but I don't know, then they might drop it if they got to pick up something else. So. Say again? Voice, voice is an interesting one. As long as there's not too much background noise. Yeah. So yeah, all interesting things. Any other questions? Cool. Okay, thanks for coming.